Welcome, dear grade 11 students, to our first chapter, Quadratic Equations. This course is prepared by Mr. Adnan Ashkar, and I prepared the PowerPoint presentation and some notes and animations. Definition of a quadratic equation. A quadratic equation is any equation that can be transformed in the form of ax squared plus bx plus c equals to 0. The condition at A is that it should be different from 0 for this equation to make sense. Because if A is 0, then ax squared is gonna be disappearing. So what remains is just bx plus c, and thus the degree of x, which is the variable. So if ax squared goes away because a is 0, then what remains is just bx plus c, and the power of x is 1. Then we call it a linear equation and not a quadratic equation. So the word quadratic is referring to the power 2 that's held by the variable x. So it's called quadratic because the exponent of the variable x, which is the degree of this equation, indeed is 2. The highest power is 2. Now the numbers a, b, and c that are the coefficients of the quadratic equation are always real numbers. They can be decimals, they can be negatives, they can be radicals, and so on. They are real numbers. And x is the unknown or the variable, as you know. Usually in equations, the unknown is named x. And our aim is always to solve the equation in order to find x. Here are examples on quadratic equations. Example 1. 3x squared plus 2x minus 4 equals to 0. Let's make a comparison. A is equal to 3, B is equal to 2, and C is equal to minus 4. So we take it with its sign. So that's A equals 3, B equals 2, and C equals minus 4. Now example 2, we have 3x into x plus 2 minus 5 into x plus 1 equals to 0. Expanding these factors, we get 3x squared plus 6x minus 5x minus 5, and reducing them, we will get 3x squared plus x minus 5. Again, a is the coefficient of x squared, which is 3, b is the coefficient of x, which is 1, and c is minus 5. This is an important note here. Ax squared plus bx equals to 0, that means that c equals to 0. And ax squared plus c equals to 0 means that b equals to 0. We call these forms the incomplete quadratic equations. But a should be always different from 0. So b can be 0 and c can be 0, but a should not be 0. Example 1 on these notes. 3x squared plus x, for example, equals to 0. Now, a is 3, b is 1, while c is 0. Also, if we have 4x squared minus 5 equals to 0, a is 4, b is 0 here because the coefficient of x is doesn't appear, and c is minus 5. This is the note I mentioned before. When you have an equation whose degree is 1, x is held to the power 1 or to the exponent 1, this equation is not a quadratic equation, and it's called a linear equation because, as I told you again and again, the degree of the equation is 1, and that means that a, which is multiplied by x squared, is 0. That's why x squared disappear. Let's recall some ideas how to factorize in order to help us solving quadratic equations. So if I have this example, 2 into x minus 3 plus 5x into 3 minus x equals to 0, and I'm gonna solve this equation to get x, what should I do? All what I have to do, as you've been taught since grade 8 and 9 and whatever, that you have to factorize in order to solve the equation, to make it as a product of factors of linear equations. So 2 into x minus 3 plus 5x into 3 minus x. What seems here is that there is a common factor, but we have to change it a little bit. So we are going to change the sign here because we are going to reverse this factor. So 2 into x minus 3 is kept as it is. The sign here becomes minus 5x is kept as it is, and this one is reversed. It was 3 minus x and now it is x minus 3. Now we take it as a common factor and what remains inside is 2 minus 5x. Now we have to solve either x minus 3 equals to 0 or 2 minus 5x equals to 0. If x minus 3 equals to 0, then x is definitely 3, and if this one is equal to 0, then its root or the answer of x is 2 out of 5. So these are called the roots or the solutions of this equation. Now let's remember the difference of two squares idea. A squared minus b squared, that's the property, equals to a minus b into a plus b. Example 1. If I have x squared minus 9 equals to 0, and as I keep telling you that we have to factorize first of all in order to solve, then it is x that's going to be x minus 3 into x plus 3, as you know, equals to 0. Then the answers or the roots are either 3 or minus 3. Here is another example. X squared minus 5 equals to 0. Then we can write it as x minus radical 5 into x plus radical 5, and thus the roots are plus or minus radical 5. Note, that's a very important note. If you have x squared plus a or plus a squared or plus any positive number equals to 0, then this has no solution in R. Why? Let's see why, and let's remember why. Of course, all of you know why, but let's make a little recall. For example, if you have x squared plus 4 equals 0, if you are going to take 4 to the other side, then you're going to have x squared equals minus 4, and that's impossible in this set of real numbers R, because I cannot get a squared number whose answer is in the negative form. So this has no solution in R. Similarly, if I have minus x squared minus 4 also, this has no solution. That's always negative and that's always positive, and they cannot be 0 at all. Now let's review the perfect square, what is meant by factorizing such expanded form and writing it in this form. Okay, so if I have a squared plus 2ab plus b squared, then it is a plus b all of it squared, and if I have a squared minus 2ab plus b squared, then it is a minus b all of it squared, and that's what we usually call the identities. And here is the first example. I have x squared plus 2x plus 1, then it is definitely x plus 1 squared. If I'm going to solve this equation, all what I have to do is just to take x plus 1, and the answer is minus 1, and we call it a double root because it was x plus 1 squared. So minus 1 is called a double real root, or they are said to be two equal real roots, because if I factorize this and or write it as product of factors, I'm going to write it x plus 1 into x plus 1, then I'm going to get to minus 1 as a root twice. So that's why we call it a double root or two equal roots. Similarly, for this example, if I have 4x squared minus 20x plus 25, I keep looking on the extremities, then 4x squared is coming from 2x, 25 is coming from 5, and I make sure by multiplying 2x by 5, which is 10x, and then multiplying by 2 in my mind to get minus 20x. So the factor or the term in the middle is in order to make sure of applying the identity. Now 2x minus 5 squared is 0, then x is definitely 5 over 2, and again, as I told you here, we call it the double root, or we call x equals another x, which are two equal real roots. Now, in order to train yourselves, you have to solve from your book Building Up Mathematics, exercise 2 in page 1 and page 38. These are, as you know, exercises here. For example, 3x squared plus 5x equals 0. All what you have to do is to factorize. So by taking, let's see here, I'll solve these two and you have to continue the others. So here I can take x as a common factor, and what remains inside is 3x plus 5 equals 0. Now this means that x is equal to 0, as you know. All of you know how to solve such equations. And here x is equal to minus 5 over 3. Okay, this is for part 1. Now if I want to solve, for example, let's see part 4. Let's solve part 4. We can solve it applying the identity, looking at the extremities. I have x squared and 64, then it's definitely x minus 8 squared. Let's make sure equals to 0. Let's make sure. If I multiply x by 8, I get 8x or minus 8x because I have a minus sign here, and then multiplying by 2 in my mind, I'm going to get 16x. Then it's definitely true, and I say that x equals 8, and we call it a double root or two equal roots. Okay, now you have to solve the others and to train yourselves.